All right, topic 7.2, photochemical smog. Now that you look out at something like that during the day, that's something you don't want. You don't want to breathe that. That's a lot of pollution. That's probably, I'm guessing, AQI above 100, maybe 150, which luckily we don't tend to have days that extreme too often in LA, although we do struggle with air pollution for sure. But yeah, so the objective here, 7.2, photochemical smog. You've all heard of smog, so we're going to talk more in depth about how it forms. So, causes and effects, and how we can reduce it. Okay, so a lot of chemistry in pollution, air pollution. We got oxygen in the atmosphere combining with nitrogen oxides with volatile organic compounds. These are anything you open in a bottle and it smells is probably a VOC. And of course, you may have heard about ozone. And one thing that drives it, especially here in LA, is sunlight and warmth that we have throughout a significant part of the year. So let's dive right into it. This smog is formed when nitrogen oxides. Remember, nitrogen is one of the biggest components of our atmosphere, the gases we breathe. And then volatile organic hydrocarbons. Volatile just means evaporates easily. You know, goes into the air, it vaporizes. So it goes from a liquid into a gas, or sometimes from a solid to a gas straight away. Organic, meaning has carbon. So this kind of just makes sure you understand when we talk about organic things, we don't think about it in the way we think of food. You know, buying food, you know, how it's grown. We think it's healthy or better for us. There's, you know, organic means different things in food. In science and chemistry and biology, when we say organic, we mean strictly it has carbon, and that's it. So technically, all food is organic because all food should have carbon in it. React with heat and smog to produce lots of pollutants. So here we have nitrogen oxides that we get, carbon oxides, and then if we add a bunch of sunlight to it, these are the secondary pollutants, the photochemical smog. Ozone, carbon monoxide, PAN, which is peroxyacetyl nitrate. Peroxyacetyl nitrate. And this stuff is really bad for plants. It really damages plants, so if plants are growing near the road or around the areas where we're getting a lot of photochemical smog, plants can start dying. And also these are really bad for our eyes. They're a real bad eye irritant. So your eyes really don't want to have anything to do with PAN. So many environmental factors affect the formation of photochemical smog. Some of which strong sunlight, which we tend to get in the summertime. Warm temperatures, also a summertime thing. So as you might imagine, all of this stuff is worse in the summer. We get a little bit of a break in the winter. Low wind, it doesn't allow it to blow out and to dilute. It just kind of mixes all together. And then something called a temperature inversion. Basically cold layer trapped near surface. Normally, right over here. Normally, the surface air is warmer than that above it, so it rises and rises and rises, but not in that inversion. That air temperature is colder than the air above it. So the warmer air kind of acts like a lid on the cold, and it just all mixes up together. And then basin-like geography. So a basin is like a sink. Basin is a fancy word for sink. So if you have mountains around you, or you're in a valley, same thing, like we are. We got mountains on, half of our side. The rest is the ocean, but that's where the wind blows off from. You're going to have more problems because that air is going to collect. Now, one place that comes up a lot is having some bad air quality is Mexico City. Very similar to us, they have a basin setup. Like you'll see, you may know that Mexico City is surrounded by some pretty major mountains. So these are all mountains in the area that kind of, the airflow is coming off the plain. So yeah, this direction, and it's getting blocked by these mountains. There's a little piece that goes through here. We see a little bit of air current coming into there, but Mexico City, basin-like geography. And of course, I mentioned us. You can see the mountains all the time surrounding the LA area. Mexico City, basin-like. Similar to LA. And again, this is what it looks like, which is pretty similar to Los Angeles that I showed you earlier. Nitrogen oxides produced early in the day. Ozone concentrations peak in the afternoon and are higher in the summer. What we talked about earlier, just the heat and sunlight, because it's produced by this photochemical reaction between ozone and sunlight. Ozone, O3. Remember, regular oxygen is O2. Add an oxygen, and you have O3. So we look at these red and blue lines. The red is the nitrogen oxides, or NOx, it's called a lot. So we see as the morning commute progresses, we have a lot of nitrogen, not so much ozone, but then once the heat comes on, by 8 or 9, 10 o'clock, we start to see this growth of smog. Photochemical smog is this nitrogen is converted into ozone and PANs, and then that brings down, because it's basically, this is the reactant, the NOx. As its reaction is progressing, the levels of it go down, because this nitrogen is now in some of these other molecules. And as we see, as the day progresses and the evening commute, we see finally a drop in ozone. So very, very big relationship between the production of nitrogen oxides and then the production shortly after of the photochemical smog. VOCs like formaldehyde and gasoline, you all know, if you're around gasoline, it evaporates very easily. If you're filling up a car, you're going to be smelling those fumes, because it vaporizes at a very low pressure and temperature. And it does, AP decided to put this in there, that trees are a natural source of volatile organic compounds. That's true. But we don't have an air pollution problem because we have too many trees. Sometimes people, they're trying to get us to get distracted from doing anything about air pollution. They say, hey, the trees make air pollution, so why should we worry? Well, because we make it way better than trees do at way bigger quantities. And just think, does that make sense? That we are being killed by too many trees. So that's a time where you see people, they're trying to argue against doing anything to make our environment better. They take a little kernel of truth and try to confuse people about it. It's done a lot. It's done global warming especially. And in all parts of science, like for biology, it happens in evolution a lot. So, and then like decomposing plants, they release some volatile organic compounds, but again, that is not what the problem is. So I want you to look through this list that you see here. Things that you do whenever you're cooking, you're probably making these VOC, especially barbecuing if you're doing coals. Although we love that smell of charcoal, right, in our barbecue. Yeah, like photocopying, I do all the time. I'm making ozone when I'm doing that. All these personal products. Look at that. Deodorizers, air fresheners. So you see somebody with one of those trees in their car to make it smell good, and you say, hey, that's releasing a lot of volatile organic compounds in your car. You sure you want to do that? Bring that up to them. Look at that, even adhesive. So we're just taping things, you're doing a project, you're taping things. Well, those are volatile organic compounds too. So it doesn't seem bad, but if you add all that up from everybody, and you may have been around, you go to a place where they just installed flooring, or just new tires, like our new buildings when they were first made here at Jordan. When you first walked in, you could smell the construction materials, and that's all volatile organic compounds. So you think of all that building up all across the city, all those new carpets, all the painting that's done, it starts to add up. All right, so photochemical smog, often in urban areas, because there's so many more motor vehicles. Remember, these cars, it is like, I love cars, but cars are really what's driving so much of our environmental problems. The air pollution here, global warming, just this massive amount of carbon we are putting up into the air. Now, what kind of cars do I drive still? Gas cars. So I'm part of the problem. I try to drive as few miles as I can, but yeah, the way the world is set up right now, it's still really advantageous, cheaper in many ways, although it's not cheaper over the long term because we have to pay the consequences. So we can reduce these things. It makes sense, right? If we reduce our nitrogen oxides and volatile organic compounds, so if you use less products, if you use less things that smell, you will create less air pollution. And we'll get into this later too, but we'll talk briefly about primary pollutants. These are pollutants that, come right out of burning something, right? Like all these transportation, cars, ships, planes make all of these pollutants. But then they get heated up by the sunlight and just warmth from the ground to make secondary pollutants. And that's your ozone and your polyacetyl polyacetyl peroxyacetyl nitrate. My apologies. Peroxyacetyl nitrate. I gotta practice that. Peroxyacetyl nitrate. Okay, so these are secondary pollutants. Again, remember, what do the pans really mess up? Think to yourself. Plants and your eyeballs. Your eyes, very sensitive to that. Okay, so they can harm human health in all these ways you see on the diagram, causing respiratory, like you can imagine. The tissues in your lungs can be quite sensitive, and also your eyes. Your eyes are sensitive, so you're going to have a lot of eye irritation. Okay, so coughing, wheezing. We've all seen people struggle coughing and wheezing, whether or not you have asthma. It can cause these issues. Maybe your eyes have even burned some days, maybe when the pollution was high and you didn't quite know it yet. Okay, and then just to practice this skill, you should be able to describe the relationship between two there's Now, we did this before there's an inverse relationship between nitrogen oxides and photochemical smog. When one goes up, the other one goes up for a while, and then the nitrogen oxide goes down as the photochemical smog goes up. It's using all the nitrogen in the smog to make it, okay, because this is a reactant. This is a product up here. Here's another example. Ozone levels are low until we get these early in the morning. These start to get some heat from the sun, and that starts to drive up the volatile organic compounds in the NOx. Okay, we see some similarity between the ozone levels and the volatile organic compounds. Okay, all right, so that is photochemical smog, and we'll move on to 7.3 next.